Hi, let's take a look at some common methods to try to compromise so-called secure systems. So we're going to look at distributed denial of service. And one of the most popular techniques of doing this is using a botnet. So we'll talk a little about what botnets are. We'll take a look at SQL injection, buffer overflow, and finally man-in-the-middle attack. So a distributed denial of service attack. So this is where we get a whole bunch of computers. It could be tens, hundreds, thousands, potentially even millions of computers, all sending information towards one victim. First example of this in a large scale was done at Yahoo. So basically you get a bunch of computers all asking for information from Yahoo. It could just be something as simple as a finger. All that a finger does is check to make sure that, say, Yahoo's website is up and running, and Yahoo would respond with an acknowledgement. If you get millions or billions of these a second, the system slows to a crawl and eventually stops working. So if you look at the diagram, we've got the bad guy way up at the top. He also has some computers that are called masters. These are the ones that he communicates with. What they do is they send the commands to what are called the slaves here, or the bots. These are all computers which have been infected, typically by malware, which allows the bad guy to control them, to get them to do anything he likes, to send emails, to send fingers, do anything that he wants to do with them. And in fact, many, they're called bot herders, the people that control bots actually rent them out. It's really cheap now. The last I looked, I think you could rent a computer for an hour for 20 cents. So you can rent a large number of computers and do anything you like with them. So in this case, we've got the bad guy, who it might be his own botnet, or we might have rented it to someone else, and they have a victim. They send the commands to the masters send the commands to the slaves, and the slaves are the ones that actually attack the victim's computer. From the bad guy's perspective, why this is good is we can certainly track the IP address, or the address of the computer that sent the information to the victim, but trying to track from the slave back to the master is going to be very, very difficult. A lot of real world botnets say they have several levels of masters, and trying to track it back to the actual attacker is nearly impossible. Basically, the only time that these guys are ever caught is if they do something silly, if they forget to use what are called proxies to log on to the masters, but use a real IP address. When that happens, we actually can trace it back to them and charge them. There's a case that happened in Spain a few years ago. The guys who controlled the botnet had a few drinks too many and logged on to the masters using the real IP address, and the police were able to track it back to them, and they were arrested for this. Another use of botnets is just to send out spam. Most spam messages now are sent via botnet. So if you wanted to send a spam message, you would rent a botnet from a bot herder for maybe an hour, and then potentially in that hour you could send out millions or even a billion spam messages. So let's take a look at the next one. This is called an SQL injection. SQL stands for Structured Query Language. This is the most usual language used to deal with databases. So if you look at the diagram, we have our external HTTP client. This is the bad guy. It's going to use the internet to go to the target web server, but what he's really looking for is the information in the database. And again, SQL just means it's structured query language. In structured query language, you structure your queries as the one shown. Say select. The star means everything from users where something is true. So in this case, the client has logged on to the web server. The web server has asked for a username and password. Rather than entering a username or a password, the bad guy types in the line shown. So this means select everything from users being the name of the table, where user ID is equal to, he just left it blank, and then the big part is this or 1 is equal to 1. If it's a logical OR, it means that if any one of the two are true, then the whole statement's true. So basically this is saying select everything from users where user ID is equal to blank, or 1 is equal to 1. This is always true. This is going to give you every user in the table. And then he adds on, and the password is equal to star. Star again means anything or everything. So basically this will, unless the people who are controlling the SQL database are smart enough to not allow this to happen, the bad guy just enters this into the username field, puts the star in the password field, he clicks enter, and it's going to give him back all the information about all the users in this database. Again, this can be stopped easily by not allowing SQL code to run from forms. This is easy enough to do. It's just a checkbox. But a lot of network administrator, database administrator types are kind of lazy or maybe not too knowledgeable, and sometimes they forget to click that box, and when they do, SQL injection can and does work very, very well if you're a bad guy. Not too well if it's your information which is being stolen. So let's look at a stack buffer overflow. This is similar to what happened with the Morris worm. If you look on the left-hand side, we've got what the system stack looks like. A system stack is just used for temporary storage. What the system stack looks like before the attack. Well, we have starting at the bottom, we've got 2 buffers, buffer 0, buffer 1. And there's also an indicator as to how big the buffer should be. Say frame pointer, every time that a program gets pushed on the stack, it's put into a frame. The frame pointer just points to where this frame is. And the big one is the return address. This is where it's going to go after this little program has finished. Where do we go next? If you're a bad guy, when that asks for you to enter something, it's going to be stored in buffer 0. Say ask for a username. What you're going to do is type in a bunch of code that you want to run. You want to type in code which is going to give you access to the shell. Then you're going to add a bunch of garbage until you come up to the point where the return address is being stored. What you want to put in there is the address of where your modified shell code starts. So basically, if you can do this and it enters the info, unfortunately, if they use the C programming language, and most people do, it doesn't check for sizes, so you can enter as much information as you like into the buffer. It's going to overwrite buffer 1, all this other stuff, overwrite the save frame pointer, and then you're going to insert where it's looking for the return address, the address of where your modified shell code starts. You can find this information from just reading the RFCs. They're called respond or return for comment. They just tell us exactly how everything is structured on the internet, how everything works. So you read the RFC, you find out where this the modified shell code is going to be, where the address is, and then you insert the address, and then your program runs, not what was intended to run. So this is an example of a stack buffer overflow, and again, this can be stopped by guaranteeing that people don't enter any more characters into the buffer than what we've programmed for. If we're going to ask for a name and we've allowed for 30 characters, it should just take in the first 30 characters, and anything else that you try to add is not stored in the computer. That stops buffer overflow. So let's take a look at a man-in-the-middle attack. So this happens on the internet. So in the example that's being shown here, we've got Jack and Jill. Jack is trying to send his account number, bank account number, say, to Jill. So it starts, we're going to use key, so this is encrypted. So it starts, Jack tries to send his key over to Jill. The problem is there's someone in the middle, Peter. Peter grabs the key, sends it over to Jill. Then Jill sends her key back to Jack. Again, Peter intercepts this. But now Peter sends his own key to Jack, not Jill's key. Then Jack sends his account number, whatever this happens to be, to Peter. Peter now has Jack's account number. So Peter then sends Jill his account number. Jill goes to send money into Jack's bank account and deposit it into Peter's bank account. This is an example of what's called a man-in-the-middle attack. Basically, The bad guy is the man in the middle, and he's between two people trying to send messages, and all the messages they're sending between each other are going through the man in the middle first. So this is very, very common in the internet world.